Okay. Alright, so we left off with the cubes. Now we're going to go to these two blocks. Alright? One feels really light, one feels really heavy. Are they the same volume?
Yes.
Yes, what is volume?
How much space it takes.
How much space it takes up. Volume is how much space it takes up. Can they see that on the video?
Yeah, now we can.
Okay. Alright, so same size. This one feels heavier, this one's lighter. We passed these around the class the other day and they felt like they were made of what?
Wood and metal.
Wood and metal. Alright, but they are the same volume as far as they do take up the same amount of space.
That means they're the same density.
So, same volume. Same volume, okay? So we're going to take our length, width, and our height of both of them. Let's start with block number one. Block number one, if we measure the length.
Wait, its color would be what, black?
Yeah, color would be black. Color for both of them would be black. So we'll write that in. So your measurement for the length is going to be 9.5. The length is going to be 9.5, and then I'm just going to flip it. What do you expect the measurement for this to be?
9.5.
The same, 9.5, because it is a square. So your length and your width are both 9.5. They're both 9.5. If you've got a calculator, go ahead and take that out. See if they'll let me write now. Yes. The length is 9.5, width is 9.5.
The other one will also be.
Well, now we're going to do height, which is up and down.
No, I mean on the other block.
Yes, I'm going to check it to be sure, but yes. So let's do the up and down height, and I got 1.2. 1.2 centimeters. Remember, we need a unit, so we're going to do centimeters after every one of these. Alright, and we're going to get the mass. Alright, so I'm going to start with this electric balance first. And I got, oh, it's in ounces, it's not in grams. You make sure you check that. So let's see, let's change the unit. 63.9 grams. The mass is 63.9 grams for block number one. Okay? All right, so now we need to multiply. Need to check the volume here. So what am I going to multiply to get the volume? Length times width times height. So 9.5 times 9.5 times 1.2.
108.3.
108.3. What is my unit for my volume?
Centimeters cubed.
I did centimeters times centimeters times centimeters with length times width times height. So it's going to be centimeters cubed. Now how do I get my density?
Divide the mass divided by the volume.
Okay, so D is equal to M over V. So I'm going to have 63.9 divided by 108. And what do I get?
0.5900277.
Yeah, that. So 0.59.
0.59, 0.59 grams per centimeters cubed. Okay? When y'all stop that video for me? Hello? How are you? Okay. So let's do block number two. Block number two, we said is black. It's a little bit shinier than the other block because it is metal. Alright, so let's get the mass. And so if I put block number two on this balance, it's too heavy, it says error. So we're going to go to the triple beam. Alright, so when you use the triple beam, should be lined up. These lines are pretty much lined up. That's called getting it calibrated. You wanna make sure it starts at 0. And so we're gonna put that on the triple beam. When you're using the triple beam, you always start with the biggest amount. So this middle part goes in the hundreds, the back part goes in the tens, and this goes in the ones. So we're gonna move the middle to 100. Did it make it budge?
No.
No.
I think that's.
So we're gonna go to 200.
Golly.
It moved, so we're gonna go to 300.
It ain't moving.
400. Oh, 400's too much. So I know it's 300 and something. I'm gonna go back to 300. So now I'm just gonna start with the tens. 10.
Oh, snap.
Oh,
A little bit.
10's a little too much. Cause see, now it's going below.
Do 8.
So I'm gonna go back to 0 on the tens, and I'm gonna start moving this.
5.
Now let's go to 5. We'll go to 5 and not enough.
Told you it was 8.
6,
7.
7.
That might be 7.5.
Well, we're at 8.5 now.
Oh.
309. So it's gonna be between 9 and 10.
So like 9.5.
9.75.
Too much.
That's too much. Oh,
Maybe.
You never know.
but it's still a little too much, so we're gonna go back just a tad bit.
9.74. It's so satisfying to watch them when it just goes up and down like a seesaw.
I'd say that's about right, and that is at 309.5. 309.5. What is my unit for mass?
Grams.
Grams. So 309.5 grams. All right. So let's look at the length, width, and height. We know what it should be.
Just double check it.
Set that back to 0. All right. Length is 9.5. Width is 9.5. Does it matter which one I do for length and width here?
No.
No. Okay. Height
1.2.
is 1.2. Okay, so that's all the same. So we don't even have to redo those calculations because we've already done those once. Got 9.5 centimeters. Make sure you're including a unit after each number. Height's 1.2. So my volume is going to be
108.3 centimeters cubed.
108.3
Centimeters cubed.
centimeters cubed.
And the other one, it don't have 0.3.
So D equals M over V, and that's gonna equal 309.5 over
108.3.
108.3.
Which
Now-
brings up a long number, but when you run it, it's 2.86.
2.86.
Divided by 108.3.
2.86.
2.86. Okay?
On the other one,
2.86 grams per
Centimeters cubed.
centimeters
On the
cubed.
first
So,
block, you didn't put 0.3 on
0.3.
108 on the first block.
Yeah.
oh, when I forgot the 0.3, I sure did, thank you.
That matters.
It matters, you're right.
Because, like, doctors, when they write their thing down, if they get it in milligrams, not grams, it could kill a person.
It could.
Yeah.
Alright,
Matters.
does anybody know what the density of water is?
No.
It's 1.
Water is 1 gram per centimeters cubed. And so you can kind of compare everything to water because that's 1. So if I put this block number 1, if I put that in water, would it float or would it sink?
It would sink. Well, no, that one would float.
That would float because that's
it's
less
less
than 1.
water.
This one would
Sink.
sink because it's more than 1.
Yeah.
Okay? Alright, so let's go to our irregular objects. Now, with our irregular objects, regular means it's like a square or
Irregular.
We'll get it in a minute.
Circle.
is, I can measure length, width, and height, if it's regular. If it's irregular, can I take these and measure length, width, and height?
No, you gotta
No.
put them in water.
Okay, I've just got 2 rocks, okay? 2 rocks. But there's no length, width, and height. There's no square shape. Let me make sure that'll fit in there. Yes, it will. Okay, so first thing I want to do is I'm going to take the mass of rock number 1. We'll just call the smallest rock number 1, and its mass is 12.6. All right, 12.6 what? Grams. All right, so does anybody remember the name of the method I have to use to get the density or the volume of this rock?
What did it start with again?
Starts with a D.
It's like deconstruction.
Displacement.
Yes,
Okay?
displacement.
Like I said, if I came and knocked you out of your desk, I'd be displacing you, right?
Yeah.
Okay, so we're going to use water and we're going to displace the water to see how much water we displace. All right, so we're going to measure. We're going to start with the amount of water. Let's start with all right, I've got 30 milliliters of water. Okay, so my starting amount right here, volume of water is 30 milliliters. So I'm gonna take this rock, that's 12.6. Am I gonna just drop it in there?
No.
No, because that's gonna splatter water, and I wanna avoid splattering water as much as I
You gotta
can.
be gentle.
Yes, I'm gonna ease that in there. And now my volume is at 34.5.
4.5.
My volume is at 34.5 milliliters. So what is the volume of the rock?
4.5.
Yeah, I'm just gonna take 34.5 minus 30, and I get 4.5. But now, what am I gonna use as my unit here?
Mass. No grams.
No grams, because grams are for mass.
Centimeters?
Centimeters
Cube.
cubed. Because even though the water was in milliliters, I got the volume of a rock, which is a
irregular object.
It's a solid. It's a regular object, but it's a solid. So since it's a solid, I want to report it in centimeters cubed. Now I just do my density formula. D equals M over V. 12.6 divided by 4.5, and I should
2.8
get
grams per centimeters cubed.
2.8. Have I got a second?
I'll correct it. Close. Not correct it. See if it's right. Yeah, 2.8.
2.8 grams per centimeter cubed. Okay? Alright, so we're going to do it again with the other rock. We're going to test another irregular object. Its mass is 17.4. 17.4 grams. Alright, so we're going to start with some water. All the air bubbles out. Alright, I've got 30 milliliters of water again. I'm starting with 30, so volume of water is going to be 30 milliliters. Alright, take the rock, slide it in, or it won't make too much of a splash.
Touchdown.
Alright, and now I'm at 36 milliliters.
Exactly.
30, say 36.5. 36.5. Alright, so what is my volume of the rock?
6.5 centimeters cubed.
6.5 centimeters cubed. Alright, so let's take 17.4 divided by 6.5, and what do I get?
2.6768 goes on forever, but
2.68.
So if I round that second decimal, I'm gonna get 2.68 grams per centimeter
cubed.
cubed. What do you notice about those two densities?
They're
pretty close.
Why are they so close?
right. How's the top one more?
Oh, it was the smaller rock, wasn't it?
Yeah.
Let's get these rocks back out.
I would think the bigger rock would have
You would think the bigger rock would have had more density?
been. I don't know. Maybe. Because I think on the blocks.
Maybe
Maybe it's
it's
because it's an irregular object.
the bigger one. They're the same,
It's the same material. So their density should be the same. In fact, it should have came out exactly equal, but probably due to human error here, there was a little mess up. But that's why they're so close. It's the same material.
Oh.
Okay? So the density is the same because it's made of the same material. But the sizes are different. But because the sizes are different, you saw differences in mass and volume. Your mass was bigger for the second one, your volume was bigger for the second one. But it's still the same material, so that density of that material is still the same. It wouldn't matter if we had these or if we had a rock this big. The density is still the same because it's still the same material throughout. It still has the same amount of atoms packed into the same amount of space.
What's the biggest amount that the triple beam balance can hold?
610.
Huh.
Any questions? Caleb, what's the density of air?
0.
The density of air depends on what type of air it is, and it depends on your elevation.
What would nitrogen be?
Because if you go, how many of you been to the mountains before? And when you go up the mountain, what happens?
The air level. the
Your
air
ears
pressure.
pop, okay? The air is getting less dense as you go up the mountain because there's less air there.
Mhm.
Because gravity pulls all that air
Down.
towards the earth. So there's less air as you go up. Same, well, we won't get into that right now. But, so air is gonna depend on what type of air. Does it have nitrogen? Does it have oxygen? Does it have carbon dioxide? What particles are in the air? And also, what is your elevation? Are you at sea level or are you at the top of a mountain?
Isn't most of like the air like nitrogen?
Yes,
Like in the atmosphere?
yes.
What type of air is like nitrogen?
All the air around us,
What's oxygen?
20-something% is oxygen.
And some.
Now, people like to think most of it's oxygen because that's what we need out of it.
Yeah.
Any questions?